diseases or disorders. Okay, because this will help us to understand the pedigree charts in a proper manner. Now, kids, whenever I talk about disorders or diseases, we have divided them into two categories. The first one are said to be chromosomal disorders. I repeat, the first set of diseases or disorders are called as chromosomal disorders. Now, what are chromosomal disorders? These are nothing but these are the disorders or diseases caused due to change in chromosome number. Now, I hope everyone knows that we are having 46 chromosomes. Okay, a normal human being has got 46 chromosomes. But if the chromosome number changes, I repeat, if the chromosome number changes, then we will say that a person is suffering from chromosomal disorder. Now, the first disorder is said to be Down syndrome, and it occurs because of 3 copies of chromosome number 21. So that individual has 47 chromosomes instead of 46. So again, this is said to be a chromosomal disorder. The another one is said to be Turner syndrome. Now, in the case of Turner syndrome, the number of chromosomes are 45. And the last is Klinefelter syndrome, where the chromosome number is only 47. Okay, right. Or rather, I can say 47 instead of 46. Now, please remember, chromosomal disorders cannot be identified by using pedigree charts. Okay, I repeat, chromosomal disorders cannot be identified using pedigree charts. So, how can we identify them? We can identify them by using a particular technique called as karyotype analysis. Now, what is karyotype analysis? It is nothing but it is arrangement of chromosomes, right, in the order of their decreasing size. I repeat, karyotype is nothing but arrangement of chromosomes in the order of their decreasing size. Now, this is done by taking amniotic fluid out, right? And from that amniotic fluid, we take the cells, and from those cells, we arrange the chromosome and we count the number. अगर number 46 है, तो हम लोग बोलेंगे बच्चा normal है. अगर number 45 या 47 है, तो हम बोलेंगे बच्चा abnormal है. Okay. So remember, chromosomal disorders के लिए there is karyotype analysis. Okay. Now, coming to the next type of disorders, and these are called as genetic disorders, or we also call them as Mendelian disorders. Now understand the meaning. When I say genetic disorders, these are the disorders caused due to mutations. Now when I use the word mutation, I am talking about a change in the gene. Now that can be either a base pair or even a segment of that particular DNA has been deleted. So any change in the gene is called as genetic disorder, or you can also use the word Mendelian disorder. Remember, you will never call Mendelian disorder as chromosomal ones. The term Mendelian disorder is applicable only and only for genetic disorders. Now, you all know that we are having 2 copies of genes. For any character, I repeat, for any character, you will be having 2 copies of genes. One from mom and one from dad. And I will say that because of this, we will definitely say that the condition is diploid. Now, you also know from Mendel's laws that the genes can either be a dominant one or it can be a recessive one. Now, when I say dominant one, the presence of even one gene out of 2 can cause a disease. Because this gene is mutated, I repeat, the gene is mutated and it is now acting as a dominant gene. So even presence of one dominant gene out of 2 can still cause the disease. Okay, but when I say recessive, minimum 2 genes are required. यानी वो म्यूटेशन के बाद जो जीन आया है, अगर वो रेसेसिव है, I repeat, अगर वो रेसेसिव है, तो उसको मिनिमम या उसके मिनिमम 2 कॉपीज होना जरूरी है. अगर एक ही कॉपी आएगा तो वो जीन का इफेक्ट नहीं दिखेगा, जबकि डोमिनेंट में एक ही जीन आएगा म्यूटेशन के बाद में, तो फिर भी उसका इफेक्ट दिखेगा. इज इट ओके? अब सुनो, अभी ये डोमिनेंट जीन या तो एक्स क्रोमोसोम पे हो सकती है या तो ऑटोसोम्स पे हो सकती है। ओके, अभी अंडरस्टैंड दिस वेरी वेल। अगर वो एक्स क्रोमोसोम के ऊपर है और वो जीन डोमिनेंट है तो मैं उसको बुलाएगा एक्स लिंक्ड और सेक्स लिंक्ड डिसऑर्डर। आई रिपीट माय स्टेटमेंट, whenever we talk about a gene present on X chromosome, right, then that gene is called as X-linked gene or sex-linked gene. You will never ever use the word sex-linked for Y chromosome. For Y chromosome, we will call them as Hollandric genes. Okay? तो अगर आपको कोई बोलता है कि उसको सेक्स लिंक्ड डिसऑर्डर है, इसका मतलब उसका एक्स क्रोमोसोम का जीन खराब हो चुका है। अभी ये एक्स लिंक भी के जो दो डिसऑर्डर्स हैं उसमें पहला है रेट्स सिंड्रोम and another one is called as Alport syndrome. Okay, now these both are present on X chromosome and you have to just remember the names. We are not getting into the details of that, right? This is not mentioned in NCERT, but still, okay, right? You need to remember dominant X-linked, Rett syndrome and Alport syndrome. Okay, now coming to autosomal. अभी ये दिमाग में फिट करना, ऑटोसोम जो है वो मेल और फीमेल के पास इक्वल नंबर में होते हैं, यानी मेरे पास भी 44 है और जो फीमेल रहेगी उसके पास भी 44 ऑटोसोम्स है। अगर उसके ऊपर की जीन खराब हो गई और वो डोमिनेंट एक्ट करती है, राइट, तो उसके वजह से वो डिसऑर्डर जो होएगा उसको मैं बुलाएगा ऑटोसोमल डोमिनेंट डिसऑर्डर और ऑटोसोमल डोमिनेंट डिसीज। इज इट ओके? राइट, अभी लेट अस कंसीडर मेरे पास क्रोमोसोम नंबर 19 है। अभी ये 19 मेल के पास भी है और फीमेल के पास भी है। लेट अस अंडरस्टैंड दिस कॉन्सेप्ट वेरी वेल। लिसन, आई एम रिपीटिंग, let us consider I am having chromosome number what 19. Okay, now this chromosome number 19 का मेरे पास दो कॉपीज होगा, एक मॉम से आएगा और एक डैड से आएगा। ओके, अभी ऐसा मान के चलते हैं कि जो मॉम से क्रोमोसोम नंबर 19 आया उसका एक जीन खराब हो गया और वो जीन डोमिनेंट भी हो गया, राइट? So the gene is undergoing mutation and at the same time the gene is also a dominant one. So I will be suffering from a disorder which will be called as autosomal dominant disorder. Okay, the first one is called as myotonic dystrophy. Myo का मतलब है muscle, right? तो muscle का यहाँ पे degradation होता है because this gene will act in degradation of muscle. और इसको मैं बुलाएगा मायोटोनिक डिस्ट्रोफी। ओके, द नेक्स्ट इज कॉल्ड एज हंटिंगटन्स कोरिया। कोरिया का मतलब है डांस। आई रिपीट, कोरिया का मतलब है डांस। तो एक हमारे पास साइंटिस्ट है हंटिंगटन, उन्होंने ऐसे देखा कि जिन लोगों में क्रोमोसोम नंबर 4 पे एक जीन है, अगर वो खराब हो गई, ट्राई टू अंडरस्टैंड दिस, क्रोमोसोम नंबर 4 पे एक जीन है, अगर वो खराब हो गई तो उसका जो न्यूरल सिस्टम है वो खराब हो जाता है और उसका हाथ ऐसे 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 शेक करता है, which is like a dance. Therefore, it is called as Huntington's chorea. Again, remember, Huntington's chorea is a dominant disease and of course it belongs to autosome. तो मैं Huntington's chorea को बोलेगा autosomal dominant disorder, right? Next is polydactyly. पॉली का मतलब है मैनी और डैक्टाइल का मतलब है तेरे फिंगर्स या मैं ऐसे बोलूंगा डिजिट्स। ओके, राइट। अभी नॉर्मली हमारे पास 20 डिजिट्स है दोनों लिम्स को मिला के। अगर एक्स्ट्रा एक आया तो मैं उस डिसऑर्डर को बोलूंगा पॉलीडैक्टालिटी। ऑफ कोर्स ये कोई डिसीज नहीं है पर ये डिसऑर्डर है और उसका जो जीन है वो क्रोमोसोम नंबर 13 पे है और ये जीन डोमिनेंट है। Is it okay? So polydactyly is said to be autosomal dominant disorder. Getting it, kids? So this was dominant. इसका मतलब एक जीन भी अगर आया तो भी वो डिसीज होएगा। Getting it, kids? Chalo. Now let's proceed to the next thing. But before that, I will take up doubts. So this was with regards to dominant one. Okay. Now let's talk about the next group, that is recessive one. Okay. Now when I say recessive one, you need to remember that two genes are required. For example, let us consider मेरे पास क्रोमोसोम नंबर 11 है. Okay. क्रोमोसोम नंबर 11 के ऊपर का एक जीन खराब हो जाता है, राइट, जो मेरे को मॉम से मिलता है. पर डैड से जो क्रोमोसोम आता है वो एकदम प्रॉपर है, तो मुझे कोई डिसऑर्डर नहीं होगा, क्योंकि ये अकेला जीन कुछ भी काम का नहीं है. फॉर मी टू सफर from sickle cell disease, I require minimum 2 genes. The reason is sickle cell disorder is actually an autosomal recessive disorder. I repeat, sickle cell disease is autosomal recessive disorder. यानी जब तक दोनों पेरेंट से मेरे को वो नहीं मिलता है, तब तक मेरे को ये डिसीज होने वाला नहीं है. Okay. The next is phenylketonuria, which we studied. And the gene for PKU is present on chromosome number 12, right? So again, for PKU to occur, I require 2 genes, both that definitely one from mom and one from dad. Is it okay? अगर एक ही जीन आया वो भी खराब वाला, तो भी वो disorder होने वाला नहीं है. The next is cystic fibrosis. Cystic fibrosis is nothing but जो हमारे lungs है, उस lungs के अंदर mucus भर जाता है, और म्यूकस के वजह से one cannot properly breathe. So we call this as cystic fibrosis, and the gene for cystic fibrosis is present on chromosome number 7. So again, I will say that this is an autosomal recessive disorder, or it is a genetic disorder. Got it? And the last one is thalassemia. Thalassemia के 2 chromosomes हैं, 11 और 16. ये हमने पढ़ा था, right? HBA and HBB. So ये भी वापस अगर तुमको थैलेसेमिया होएगा तो तुमको मिनिमम 2 जीन्स चाहिए, एक जीन से काम होने वाला नहीं. Is it okay? Right. So this is what we call it as recessive disorder. Either it can be autosomal or it can be sex-linked. Now sex-linked में सबसे पहला है color blindness. Now, when I say sex-linked, again I am using the word X-linked disorder. Color blindness होने के लिए आपको वापस minimum 2 genes का requirement है. Okay, and the next is hemophilia, which is also again an X-linked disorder. यानी जब तक तुमको अभी listen, now this is something important which I'm trying to tell you. अगर मैं मेल की बात करता हूं, तो मेल में एक ही जीन अगर आया तो भी वो लड़का कलर ब्लाइंड होगा, बट लड़की को कलर ब्लाइंड होने के लिए मिनिमम 2 जीन्स चाहिए. यानी उसका फादर का भी जो एक्स क्रोमोसोम है वो खराब वाले जीन को कैरी कर रहा है, और उसकी मम्मा से जो एक्स क्रोमोसोम आया उसका भी जीन खराब है, तो ही लड़की कलर ब्लाइंड होगी. और इसके लिए जब भी हमने पॉपुलेशन स्टडीज किया तो ऐसे देखा कि पूरे पॉपुलेशन में 8% मेल्स आर कलर ब्लाइंड, whereas only 0.4% females are colorblind. Got it? Right. So this is the thing which you need to remember. अगर लड़की को X-linked disorder होएगा, इसका मतलब उसके पास दोनों X क्रोमोसोम के ऊपर के जीन्स खराब है. Getting it? And the next is hemophilia, right, which is again a X-linked disorder. Got it? So this is the table which is very important before we start with pedigree analysis. Okay, so I hope this table is very clearly understood by you people. Now whenever we talk about pedigree charts, okay, so now one thing is very common, or rather one thing is very clear, that pedigree can be used only for finding out genetic disorders. For finding out chromosomal, you cannot use pedigree. Okay, for that you are going to use karyotype analysis. Okay, now listen, in pedigree charts we are going to use some symbols. The first symbol, which is nothing but circle, indicates female, right? The second symbol, which is square, indicates male. Okay. Now, the third symbol with a shaded circle indicates deceased, female. A square with shaded indicates deceased, male. Okay. Next. Now, understand this symbol very, very well. If you have a circle with a dot, then we call this particular female as carrier female. Now, understand the meaning of the word carrier female. Listen, carrier female is that female which is having a recessive gene with her, right? But the other gene is a dominant one. So this particular female is not suffering from any disease, but she is carrying the gene for that disorder. For example, okay, let us consider I'm having a female, and this female is a carrier for color blindness. So this particular X chromosome is the dominant one, and this particular X chromosome contains the gene for color blindness, but this gene is not going to get expressed in this female. So this particular female is called as carrier female. Remember this very, very well. So a circle with a dot indicates a carrier female. Is it okay? Now, the sixth symbol. Now listen up. If you have a female and if you have a male, and there, if you can see that there is a bridge between male and female, it indicates that this particular pair is a couple, right? Getting it? So this is a symbol for something called as mating. Is it okay? Very clear? Remember the first symbol? Normal female, normal male, deceased female, deceased male, carrier female, normal mating. Okay. Now, seventh one. If there are two lines, we will call this as mating between relatives. Or right, यानी उसी फैमिली को अगर वो बिलोंग करते हैं, तो अगर ऐसा सिंबल आप देखेंगे तो इसको हम लोग बोलते हैं mating between the relatives, or many people call this as consanguineous mating. Okay, consanguineous का मतलब है उसी particular family को belong करने वाले लोग. Remember this symbol very, very well. Is it okay? Right. Now let us come to the next symbol. Now the next symbol is actually a diamond. Now if I see a diamond, तो diamond का मतलब होता है इसका sex unspecified है. यानी हमको मालूम नहीं है कि ये मेल है या फीमेल है. Is it okay? As I told you, this is nothing but mating between the relatives, or you can also call it as consanguineous mating. Okay, consanguineous mating. Getting it? That is mating between the relatives. Is it okay? Abhi, you can have one more symbol over here, that this particular diamond with shaded. So can I say here the sex is not specified, but the individual is a deceased one. Okay, very clear? Super. Abhi, now there are some more symbols which you need to remember. If you have a square and if you have a circle, and then you are having like this. So remember that this particular couple has got two children. One is male and the other is female. Okay, right. So this indicates that this particular generation is generation 1 or parental generation, and this is said to be generation 2. Right. Remember these symbols very, very well. Okay. Now, sometimes they also have for carrier female, half shaded like this. So this also indicates that the female is a carrier one. Okay, remember this very well. Now, if I show you that this particular male is shaded like this, so we will say that the parents are normal, right? But the male is affected, okay, or the male is having disease. Now, the same can be also considered for a female. So the female is affected. Is this clear? Right. So these are the symbols which we normally use in pedigree analysis. Now, I will go give you one more example. So these are the parental generations, or I can say a couple, right? ये उनका first generation का बच्चा है. Now, this particular male is marrying a female outside the family because there are no two bridges. और ये उनके बच्चे हैं. So you can clearly make out that, right? This is generation 1, this is generation 2, and this is generation 3. Okay, right. So I have now shown a family pedigree or a family pedigree chart which shows that the parents never suffered from any disorders, neither their children. But, okay, but here in the third generation, the male child is affected. Is it okay? Right. So you can actually plot a pedigree chart and you can find out that who is responsible for this particular disorder. Now, according to this pedigree chart, इनके बच्चे अगर सफर कर रहे हैं तो पॉसिबिलिटी है कि इसकी जो मम्मा है जो बाहर से आई है वो कुछ जेनेटिक डिसऑर्डर लेके आ रही है. Is it okay? Right. So this is how we can actually trace genetic disorders. As I told you, you cannot find chromosomal disorders by using pedigree charts. Okay. So the basics are clear. These are the symbols which we are going to use. Right. Okay. If you see two bridges, it is nothing but mating between the relatives or consanguineous mating. If you see a diamond or a triangle, whatever, right, okay, you will say that sex is unspecified. And whenever there are shadeds, you can say that it is a deceased particular individual. It can either be a male or it can either be a female. Okay, right. Now, let's proceed one step. Now, kids, remember again one important thing about pedigree charts. Now, there are some unwritten rules, or I can say there are some hints which you need to follow while solving the pedigree. Okay, they will actually help you out. Not necessarily that the hints are always useful, but they give you an idea how to find a particular genetic disorder. For example, listen, so now understand this. Just 1 minute. I have got a particular table which I will share with you, right? Listen now. Now, let us consider I am having a particular couple in which you can see that the mother is a carrier for the genetic disorder, whereas father is normal, right? Now, understand this. This is the first male child. This is second male child. This is third child who happens to be a female. Okay. Now understand something very, very important. Now, as this particular female is a carrier, we have written, or rather, we have included a dot in the circle, right? Now, if you can see, this particular girl is normal. And let us consider that this boy is deceased. Now listen, kids, understand this basic. If it is X-linked recessive, I repeat, if it is X-linked recessive, for example, okay, color blindness is said to be X-linked recessive. तो इसकी जो मम्मा है, ये carrier female है, right? और इसके जो डैडी है, ये तो normal male है, क्योंकि ये आपको दिख रहा है clearly, right? अभी इसका जो लड़का है वो अफेक्टेड है, तो मैं बोलूंगा कि मम्मा ने ये जो एक्स क्रोमोसोम है ये अपने बच्चे को दिया और डैडी ने अपना वाई क्रोमोसोम इस बच्चे को दिया, तो ये बच्चा कलर ब्लाइंड हो गया, राइट? ना अभी ये जो लड़का है इसको एक्स क्रोमोसोम ये वाला मम्मा से मिला और वाई क्रोमोसोम डैडी से मिला, Is it okay? Now, this particular male has now given X chromosome to the daughter, and this mother has also given normal X chromosome to the daughter. Very clear? Right. अब सुनो, इसको थोड़ा सा और आगे लेके जाते हैं. ये जो कलर ब्लाइंड लड़का है, उसकी शादी एक नॉर्मल फीमेल से होती है. फीमेल इज नॉर्मल, राइट? उनके वापस 3 बच्चे होते हैं, 1, 2 और 3. ठीक है? राइट. अब सुनो ध्यान से. The female is normal. Now you need to remember one basic thing again. The daughter will always receive one X chromosome from father. यानी फादर का जो भी एक्स क्रोमोसोम है वो बाय डिफॉल्ट अपने लड़की के पास ही जाएगा. लड़के के पास कभी भी एक्स क्रोमोसोम नहीं जाएगा. ध्यान से सुनना मेरी बात. जो लड़की है उसको बाय डिफॉल्ट फादर का एक्स क्रोमोसोम मिलने वाला है. ओके, तो मैं ऐसे बोलूं क्या, ये एक्सी वाला क्रोमोसोम इस लड़की के पास गया और ये एक्स वाला क्रोमोसोम उसको उसकी मम्मी से मिला. So can I now say that this particular female is a carrier female, right? Now, जो लड़के होते हैं उनको by default Y chromosome father से मिलता है और X chromosome mama से मिलता है. So you can see that both the males are normal males, okay? Whereas my female is a carrier female. Is it okay? So if you now see the pattern, you can see that this particular XC wala gene is transferred from mother to the son and from son to the granddaughter. Okay, so female, then there is male, then there is again a female. So we call this as criss-cross inheritance. Okay, that is, here the gender is changed in the second generation. And in the third generation, again, you can see a female, carrier female. Is this very clear? Let me know. Unwritten rule number 1, X-linked recessive follows criss-cross inheritance. That is, the gender will be changed, right? Okay. Now let us come to the next important hint. Now understand this, okay, kids? When I am saying a recessive disorder, it can be either autosomal, और अगर मैंने sex linked बोला तो वो criss cross करता है, अगर वो X linked है तो, right? Okay. अभी हम बात करते हैं autosomal disorder की. Now let us consider that this is the couple. Now please remember, for autosomes we will never ever use the carrier wala symbol. I repeat my statement. For autosomal disorders, we will never ever use the carrier wala symbol. Okay, right? That we have to figure it out. Now, let us consider this is generation 1. Okay? Now, so I'll make a more change so that it is more easier for you guys. Now you can see that the parents are normal parents. That means they are not suffering from any disorder. Okay. But उनके जो 4 बच्चे हैं उसमें से 2 बच्चे genetic disorder से suffer कर रहे हैं. Okay. One is female and another is male. Now, the moment you see a female suffering along with a male, you will come to a conclusion that it is not X-linked recessive, neither it is X-linked dominant. क्योंकि अगर X-linked recessive होता, सुनो ध्यान से, अगर X-linked recessive होता, तो मैं बोलूंगा कि इसका डैडी भी तो डिसीज्ड होना चाहिए, पर इसका डैडी तो नॉर्मल है, राइट? जबकि इसकी लड़की डिसीज्ड है. और आपको मालूम है कि 2 जीन में से एक जीन डैडी से आएगा और एक जीन मामा से आएगा। तो अगर ये ऐसा है तो ये डैडी बी को डिसीज होना चाहिए, पर यहाँ पे डैडी नॉर्मल बताया है, इसका मतलब ये एक्स लिंक्ड रेसेसिव डिसऑर्डर नहीं है। इज इट ओके? राइट। So my X-linked recessive wala thing is ruled out. You understood, kids? Super. Next. Now you can also see that here this particular female is a normal female और उसकी जो लड़की है वो affected है। अभी autosomal recessive का एक पैटर्न हमने देखा है। पैटर्न ये है कि वो जनरेशन स्किप करता है। स्किप का मतलब क्या है? लिसन, now let us consider this is generation 1. जनरेशन 1 में ये नहीं दिख रहा है, जबकि जनरेशन 2 में ये दिख रहा है, जनरेशन 3 में ये नहीं दिख रहा है और जनरेशन 4 में ये दिख रहा है। तो मैं बोलूंगा कि ये जो डिसऑर्डर है इसने ये जनरेशन को स्किप किया, ये जनरेशन को स्किप किया, right? So it is skipping the generation. So whenever the generations are skipped, right, we will come to a conclusion कि ये recessive है। और जैसे मैंने बताया ये X-linked recessive तो नहीं है, इसका मतलब ये autosomal recessive है। ओके, अब सुनो, autosomal recessive को बनाने के लिए, now understand this very well now kids, इसको रेसेसिव बनाने के लिए कुछ चीजें तुमको दिमाग में रखनी है। Now, recessive can be expressed only when 2 genes are available. I told you that before itself, that let us consider it is a sickle cell disease. For sickle cell disease, you need to have 2 genes. Of course, one will come from mom and another will come from dad. Is it okay? But are these parents suffering? No. So can I say their genotype will be like this? Okay, right. And the reason this particular child is suffering from that particular disorder is because उसके जो दोनों parents है वो heterozygous है for sickle cell disease, or we can also call them as carrier. But as I told you in pedigree, you never use a dot for the autosomal disorders. You have to figure out on your own. Okay, right. अब सुनो, अब ये जो लड़का है ये नॉर्मल है। अभी इसका जीनोटाइप या तो कैपिटल ए हो सकता है या तो कैपिटल ए स्मॉल ए हो सकता है। अभी तुम बोलेगा कैसे? तो लिसन, कैपिटल ए मॉम से आया, कैपिटल ए डैड से आया, इसके लिए वापस ये नॉर्मल है। कैपिटल ए मॉम से आया, स्मॉल ए डैड से आया, तो भी ये नॉर्मल है, बिकॉज दिस इज ऑटोसोमल रेसेसिव। Getting it? Here also the same. Capital A, small a. Here it is small a. Why small a? Because this particular son is deceased. Got it? Right. So now this particular female is going to be a normal one. Now listen up, understand this. इसका जीनोटाइप कंपल्सरी कैपिटल ए स्मॉल ए ही होना चाहिए। तुम बोलेगा क्यों? क्योंकि कैन यू सी यहाँ पे ओके राइट, जो हमको दिख रहा है राइट वो एक डिसीज है। तो डेफिनेटली मैं ऐसे बोलूंगा कि इसका अगर मैंने कैपिटल ए स्मॉल ए, हाँ चलो ले सकते हैं, कैपिटल ए भी ले सकते हैं, तो इसका जीनोटाइप आएगा कैपिटल ए स्मॉल ए, इसका आएगा कैपिटल ए स्मॉल ए या तो कैपिटल ए, उसका मेरे को फर्क नहीं पड़ता है, नहीं इसका ऐसे ही आएगा, कैपिटल ए स्मॉल ए ही आएगा, क्योंकि वन यू विल गेट फ्रॉम फादर एंड अनदर यू विल गेट फ्रॉम मदर। इसका भी जीनोटाइप कैपिटल ए स्मॉल ए ही होगा, बिकॉज दिस चाइल्ड इज गोइंग टू सफर फ्रॉम डिसऑर्डर। So can you now see that this is how you can have autosomal recessive? Okay, clear? So it is skipping the generation. तो ये generation में तुमको कोई नहीं दिख रहा है, इधर भी कोई नहीं दिख रहा है, पर इधर दिख रहा है और इधर दिख रहा है। तो normally autosomal recessive generation को skip करते हैं, ये थोड़ा सा याद रखना। There is a pedigree given to you, okay, and you have to find out that what is this? Is it a X-linked dominant, or is it X-linked recessive, or is it autosomal dominant, or what? Think about it, right? Yeah. The male is affected, the female is not. All the kids are affected, right? This particular affected female is marrying a normal man, and you can see that उनके दो बच्चे हैं, एक लड़का नॉर्मल है और एक मम्मा अफेक्टेड है. आपको सब दिमाग में लेके आने का है. अगर वो एक्स लिंक्ड होगा तो क्या होगा, अगर वो वाई लिंक्ड होगा या होलैंड्रिक होगा तो क्या होगा, अगर ऑटोसोमल रिसेसिव है तो क्या होगा, ऑटोसोमल डोमिनेंट है तो क्या होगा.
सर
बोलो.
एक्स लिंक डोमिनेंट.
क्या बोल रहे हैं?
एक्स लिंक डोमिनेंट.
X-linked dominant. Okay, let us see X-linked dominant. Now, I told you, please Karthik, now think over this. I told you that XD, yani X-linked dominant, will be given to this. It will be given to this and it will be given to this. But what about this male? The male will get X chromosome from mama or from daddy?
डैड.
Huh?
डैड.
Dad से X chromosome लड़के को आता है?
नहीं नहीं नहीं,
माँ से आता है.
हाँ, mom से आता है ना?
हाँ.
Of course. So can I say Y chromosome is given by dad, and this mama is normal. So definitely it is not X-linked dominant.
Autosomal dominant.
Huh?
Autosomal dominant.
So let us work out on autosomal dominant. So let us take this. Right? Yes, it can be autosomal dominant. Is it okay? Because the first thing which I came to know is that it is not skipping any generation. तो अगर वो generation skip नहीं करता है तो usually वो dominant होता है. Is it okay? Very clear?
Yes, sir.
Yes, sir.
Now, I will give you one more hint. Listen. If you see properly, right, okay, all the kids are affected. So of course, ये X-linked recessive भी तो नहीं हो सकता. क्या हो सकता है X-linked recessive?
नहीं हो सकता.
नहीं हो सकता. Of course, you can see that even though let us consider this is like this, right? Okay. तो उसकी सारी लड़कियां जो है ना वो कैरियर होगी पर कोई भी affected नहीं होगी. You are getting my point?
हाँ.
Very good. Now, we will take one particular pedigree which is given in your NCRT book. Okay, I will just mute everyone. Now, you can see there is a pedigree given in the NCRT book. Now, the first pedigree, if you can see properly, is that the mom is affected. Can you see? Yes, okay. Then you have 1, 2, 3. Then you are having one more child. 1, 2, 3, 4. Okay, 4 kids are. Okay, out of which one male is affected, whereas other male is normal. Right? Fine. Next. This normal male marries a normal female. Okay. And they have got 3 children. 1, 2, and 3. This female is affected. And now you have 3 children. 1, 2, and 3. So now let us consider this particular pedigree. Okay. Now let us consider this 1. So you can see that generation 1, the kids are affected. Oh, sorry, the parents are affected. Generation 2 affected. Generation 3 affected. So it is not skipping any generation. Okay, right. Therefore, I will come to a conclusion, or rather, I can come to a conclusion that it can be autosomal dominant. So let us consider autosomal dominant. Capital A, small a, small a, small a. Okay. स्मॉल ए स्मॉल ए हो सकता है, हाँ हो सकता है. कैपिटल ए स्मॉल ए हो सकता है. स्मॉल ए स्मॉल ए स्मॉल ए स्मॉल ए. Therefore, all the kids are small a small a small a small a. Again, capital A small a small a small a capital A small a small a small a. So this can be autosomal dominant. I repeat, it can be autosomal dominant. Very clear, right? And this pedigree which is given in your textbook, right, is of myotonic dystrophy. I told you that myotonic dystrophy is nothing but it is also autosomal dominant disorder. So this pedigree is showing autosomal dominant disorder. Okay, now please understand this. I am now showing you something not for making you confused, right? But to make you aware that there can be one more conclusion which can be drawn. Let us see that. Now you can see here, I have worked out one more method. Okay. Here I have taken this as X-linked dominant, Rett's syndrome. Okay. So this particular female is suffering from Rett syndrome, and this is the genotype of this particular female, and this is the genotype of this particular male. So you can see that this girl is normal, this male is a sufferer because उसको या तो ये X मिल सकता है या तो ये X मिल सकता है. तो ये लड़का नॉर्मल है, सॉरी डिसीज है, ये लड़का नॉर्मल है, उसकी वाइफ भी नॉर्मल है, इसलिए उनके सारे बच्चे नॉर्मल है, तो कोई टेंशन ही नहीं है. अभी इसको देखो, ये फीमेल अफेक्टेड है, इसका मतलब उसको ये XD वाला क्रोमोसोम उसकी मॉम से मिला और नॉर्मल X वाला क्रोमोसोम उसको डैड से मिला. As it is X-linked dominant, even a single gene can play havoc, right? A single gene is going to be responsible for disease. तो ये है नॉर्मल मेल है, 3 बच्चे हुए, ये लड़की अफेक्टेड निकली क्योंकि उसको XD मम्मा से मिला और X डैडी से मिला, राइट? सो ऑटोसोमल डोमिनेंट और एक्स लिंक्ड डोमिनेंट जो है उनका पेडिग्री पैटर्न या उनका इनहेरिटेंस जो है वो नियरली सेम होता है. तो आपको एग्जाम में कभी भी ऐसा कंफ्यूजन वाला क्वेश्चन नहीं देंगे. अगर वो लोगों ने ऑप्शन में ऑटोसोमल डोमिनेंट दिया तो उसके साथ साथ वो आपको एक्स लिंक्ड डोमिनेंट नॉर्मली नहीं देंगे. ओके, बिकॉज दैट विल मेस अप द एंटायर पेडिग्री. Because you can see that here I have derived both the pedigrees, that is X-linked dominant also and autosomal dominant also. Okay, very clear. So this is the pattern, and as I told you, normally they will never give you anything by which you are going to get confused. Okay, so this is the pedigree, another pedigree chart given in your textbook. Okay, now let us try to decode this. Now if you can see, generation 1 or the parental generation is not suffering from any disease. Okay, whereas generation 2 is suffering from a disease. यानी इनके बाद का ही. But now I am focusing on this particular couple. यानी जनरेशन 1 में ये डिसीज नहीं दिखा, ये जनरेशन 2 में ये जो लड़की है उसके पास भी डिसीज नहीं है, पर उसके बच्चों के पास ये डिसीज है। तो अगर तुम थोड़ा सा सोचेगा तो ये डिसीज जो जनरेशन 3 में दिखती है वो 2 को स्किप किया और 1 को भी स्किप किया। तो as it is skipping the generation, I can come to a conclusion that it is recessive. So my primary investigation says that it is a recessive disorder. Now, I need to know that is it a X-linked recessive or is it a autosomal recessive? Okay, so let's analyze it. Now, in this generation 2, you can make out that this particular female is a affected or a diseased female. अभी इसको अगर X linked recessive बनाने का है तो एक X क्रोमोसोम उसके फादर से आएगा और एक X क्रोमोसोम उसके मदर से आएगा, बराबर? तो ये अफेक्टेड होगी। और अगर तुम पेडिग्री को देख रहा है तो इसका जो फादर है ये तो नॉर्मल है, यानी इसका जीनोटाइप ऐसे होगा। I hope I am very clear on this particular front. For this female to be affected, she needs 2 genes present on X chromosome, and that too both the genes should be faulty. As a female, she always receives X chromosome from father. Of course, one of the X chromosome. But now here you can see that this father is a normal father. So, इसका ये gene इसके पास आएगा, तो definitely ये affected नहीं होगी। तो मैं बोलूँगा कि मेरा जो पहला कंडीशन था एक्स लिंक रेसेसिव था, ये रूल आउट हो गया। तो अभी ये होगा ऑटोसोमल रेसेसिव। करके देखते हैं। देखिए, लेट अस कंसीडर इसका जीनोटाइप कैपिटल ए स्मॉल ए है, इसका भी जीनोटाइप कैपिटल ए स्मॉल ए है। सो बोथ आर heterozygous for that particular disorder. So they are not going to suffer because of that gene, because the gene is recessive gene. Okay. Now, इसका genotype can be capital A or it can be capital A small a, कुछ भी हो सकता है. Is it okay? But इसका genotype compulsorily small a आएगा. Getting my point? क्योंकि ये suffer कर रहा है. Now, let us come to this particular female. This is something very, very important now. ये फीमेल का जीनोटाइप निकालना हमारे लिए सबसे इंपॉर्टेंट है. इसका जीनोटाइप बाय डिफॉल्ट कैपिटल ए स्मॉल ए ही होगा. क्यों? क्योंकि इसका लड़का अफेक्टेड दिख रहा है, तो ऑफ कोर्स ये स्मॉल ए इधर से आएगा और इसका जो हस्बैंड है उसके पास भी तो कैपिटल ए स्मॉल ए ही होगा, तो ही इसका जीनोटाइप ऐसे आएगा और वो सफर करेगा फ्रॉम दैट डिसऑर्डर. इज इट ओके? इसका जीनोटाइप स्मॉल ए आएगा, इसका जीनोटाइप या तो कैपिटल ए या तो कैपिटल ए स्मॉल ए आएगा. इज इट ओके? इसका जीनोटाइप वापस या तो कैपिटल ए या तो कैपिटल ए स्मॉल ए, कैपिटल ए स्मॉल ए. So from this pedigree, we can come to a conclusion that this particular disorder is autosomal recessive. It can be either cystic fibrosis, it can be PKU, it can be sickle cell disease, okay, or any disease which is autosomal recessive. Is it okay? So we have decoded both the pedigrees given in your textbook. Okay, right. Now I'm taking some doubts. So in this particular pedigree, you can clearly see that, right? Okay. The genotype of the parent, the one who is suffering, okay, the genotype of the daughter and the granddaughter is the same. Okay, so this is how you can actually analyze the pedigree charts. Right now, I have given you a lot of pedigree charts for practice. Right? Okay, you can practice them and then we can definitely do the doubt solving. Okay.